Hi, my name is AJ Gemmer, and I am the CTO of Lunar Outpost, a company focused on dual-use technologies that can enable a sustainable presence in space while having a positive impact here on Earth. In this video, I'm going to tell you about how Verizon 5G can enable the next era of landmark lunar missions. The space industry is quickly transitioning from solely large government organization and contractors to a more commercial-focused ecosystem where innovation thrives. A quote from NASA's administrator Jim Bridenstine best describes this: "We are going to the moon. To do so sustainably, we are going to expand partnerships with industry." So why does this matter to Verizon, and where does lunar robotics fit in? To enable sustainable missions in space, you need to use resources that are already there. This is called in situ resource utilization, or ISRU. For example, we know that there is ice on the moon in permanently shadowed craters near the moon's poles. Using water from this ice to sustain astronauts, grow food, and refuel rockets is a popular concept to make long-term activities on the moon orders of magnitude cheaper, safer, and more accessible to private companies. In order to make long-term lunar outposts a reality, we need to identify and survey the best spots on the moon for resource utilization. This is where Lunar Outpost's MAPP rovers come in. Our mobile autonomous prospecting platform rovers can operate in swarms on a planetary body's surface to locate and identify usable resources. MAPP is currently being developed by Lunar Outpost through a contract from NASA and our own internal research and development fund. Part of MAPP's mission, outside of looking for resources, is to serve as a mobility platform to carry enabling payloads and instrumentation that will be crucial to lunar operations. This feature helps MAPP serve a plethora of different missions while accomplishing its resource prospecting objectives. MAPP enables a new perspective on space, one that envisions space as an accessible, profitable place for humans to explore, discover, live, and work while alleviating resource shortages here on Earth. That said, space robotics presents a unique set of challenges, ones that are necessary to overcome to enable a sustainable presence past Earth. 5G solves some problems completely while alleviating others. Current NASA CLPS missions are going to use 802.11 Wi-Fi for communication between landers and payloads, limiting bandwidths, signal range, and device connectivity while drawing unnecessary power and adding weight and processing requirements. Right now, Lunar Outpost MAPP is at a stage where it will be able to drive, send back short videos, create topographical maps from laser scans, and drill for water, all while making its own decisions and planning its paths completely autonomously. However, the data generated by all of MAPP's sensors must be compressed and carefully evaluated to determine which data is the most valuable to be transmitted back to Earth. Having access to 5G communications on the moon would change that, add significant capabilities, and transform MAPP's missions in many important ways. The low latency and high throughput and reliability of 5G will allow scientists and students from around the world to create missions of their own design and control MAPP rovers on the lunar surface in nearly real time. MAPP sensors are capable of generating large volumes of surveying and video data. With 5G comms, MAPP will be the first off-planet rover to stream 4K, 360-degree high-definition video, bringing the intrigue and wonder of space right to people's smartphones. The energy efficiency of 5G will enhance MAPP's mobility, allowing MAPP to drive further, explore more challenging terrain, and survive longer on the lunar surface, making space even more accessible to the public. And as more and more cargo landers are sent to the moon, swarms of connected MAPP rovers will work together to accomplish more complex, cooperative tasks, requiring persistent connectivity between themselves, their landers, and orbiting satellites racing overhead, all acting as interconnected devices. This vision allows Verizon to establish the first true extraterrestrial communications network, bringing space to the world. MAPP, powered by Verizon 5G, will have significant impact on education, the scientific community, and the aerospace industry while inspiring a new generation of STEM students to pursue careers in science, technology, and engineering. The Verizon MAPP 5G is literally a moonshot in every sense of the word, and we couldn't be more excited than to seize this opportunity to work with Verizon and change the way we all think about the future of space.